E-waste. What is e-waste? Does it ring a bell? Did you ever hear that term? E-waste is the term used to cover all electrical and electronic equipment and its parts that have been discarded by its owner as waste without any intent of reuse. It is also referred to as WEEE from waste, electrical and electronic equipment, or electronic waste, or e-scrap, depending on the region. Electrical and electronic equipment, and therefore also e-waste, can be classified into the following 6 categories. Temperature exchange equipment, such as refrigerators or air conditioners, screen and monitors, lamps, large equipment, such as washing machines, heating systems, electric stoves, photovoltaic panels, etc. Small equipment, such as vacuum cleaners, microwaves, toasters, radios, etc. And small IT and communication equipment, such as cell phones. Considering the numerous applications of all electronic items, it is not hard to imagine that the composition of e-waste is very diverse. In general, it is characterized by containing a combination of metals, such as steel or aluminum, plastics, chemicals, for example in batteries, glass, or other substances and materials, or even mix of materials, such as this orange part called flexible PCB, or this green part with many little small parts, where the green part is called FR4, and all the little small parts consist of copper, gold, and many other materials such as silicon and glass, etc. Among the substances of particular interests are a very wide range of metals, including rare earth metals such as lanthanum, cerium, praseodymium, precious metals such as gold, silver, and palladium, or other metals such as copper, aluminum, or iron, which have, together with plastics, often used as covers, a high intrinsic value. In addition, e-waste also contains many hazardous materials, heavy metals for example, such as arsenic, chromium, mercury, lead, cadmium, etc., and chemicals such as chlorofluorocarbon used in cooling units, polyvinyl chloride used as cable insulator, or various flame retardants such as polybrominated biphenyls. This table shows the material composition of 4 e-waste categories in percentage. In fact, up to 60 elements from the periodic table can be found in complex electronics. In spite of many of them being scarce and recoverable, recycling rates are very low, often due to the current high economic costs to do so. This, of course, represents a threat to resource security over the long term. By now, you might be wondering, how much e-waste is generated in the world? E-waste is the fastest growing waste fraction. According to the United Nations University, the global quantity of e-waste generation in 2010 was around 33.8 million tons. Only 4 years later, this value had increased to 41.8 million tons, representing approximately 2% of the total global waste generation. That means an increase of 25% only in 4 years. So now, I would like to ask you to match the generated amounts per year per e-waste type. Can you guess which of the e-waste types amounts to 12.8 million tons per year? Or which one amounts to 1 million tons per year? Let me help you a bit on this. 12.8 million tons of small equipment are generated per year, whereas 1 million tons of lamps are generated per year. The other e-waste types correspond to the amounts as shown with the numbers. From the 41.8 million tons generated in 2014, only 6.5 million tons were reported as formally recycled. That represents 15.5% of the total generated amount. The collection and management of e-waste heavily depends on the legislation of each country. However, developing nations often lack the legislation on this type of waste, the infrastructure needed for handling it properly, or treatment standards, which leads to improper practices, as we will see later. An important legislative document that also affects e-waste is the Basel Convention, effective since 1992. The Basel Convention was designed to reduce the movements of hazardous waste between nations, and especially to prevent developed countries from illegally dumping waste in developing countries, where recycling infrastructure is typically absent. Depending on the constituents and materials of e-waste, this can fall under the scope of the Basel Convention and be categorized as a type of hazardous waste. Thanks to this convention, trading of second-hand equipment and e-waste containing hazardous materials is legal only if it is allowed by both sending and receiving countries. Plenty of information on the Basel Convention is available on the internet. So what happens currently with e-waste? We distinguish these four main practices. The first practice consists of official take-back systems. In this case, e-waste is mostly collected by municipal collection services, retailers such as stores or supermarkets, or commercial pickup services. The collected e-waste in this case goes to state-of-the-art treatment facilities which recover the valuable materials in an environmentally sound way and reduce the negative impacts. Here we see the percentages of the total generated e-waste that is annually handled like this in several countries. This picture shows an operator in a collection point for e-waste in Switzerland. Whereas in this second picture, we see operators of an e-waste recycling company in Bolivia. The second practice involves disposing e-waste in mixed residual waste, such as shown here in this bin, full of paper, plastics, and e-waste. Small equipment, such as lamps, USB sticks, phones, electronic toothbrushes, etc., are often thrown into the normal dustbins. Often, this trash is brought to landfills or incineration plants, leading to a loss of potential resources and negative environmental impacts. It is estimated that 0.7 million tons of e-waste are handled like this in the European Union. The amount of e-waste that is disposed of in waste bins is unknown for other regions. The third practice involves collecting e-waste outside of official take-back systems. In developed countries, e-waste is also collected by individual waste dealers or companies and then traded through various channels. This e-waste is usually not reported, and it is often not treated appropriately, and possibly it is shipped off to developing countries. The export of e-waste is motivated mainly by two reasons. Often, inexpensive second-hand equipment and raw materials are demanded in less developed regions. However, as the cost of waste disposal skyrocketed in developed countries, shipping e-waste to other regions with less stringent environmental regulations is cheaper. Many countries in Africa and China have been common destinations for such exports. When this trade occurs, with materials subject to control under the Basel Convention, this could be classified as waste trafficking or waste crime, rather than legitimate trade. Deliberate misclassification of waste types and false declarations of waste products as reusable products are typical fraudulent examples. This map shows the main intercontinental exports of e-waste. If you happen to be living in any of these countries, and you witnessed one of these e-waste sites next to your homes or in your neighborhood, why don't you share it with us? Take some pictures and post them on the forum. I'm sure it will be very interesting for all your colleagues or other colleagues following the course. Once this exported e-waste reaches the shore, it is typically dumped indiscriminately, spilled accidentally, or managed improperly, causing severe health problems, even death, and poisoning the land, water, and air for decades or centuries. The fourth and last practice involves informal collection and recycling of e-waste in developing countries. A big portion of this e-waste that is imported into developing countries, as well as the small amounts of e-waste generated within these countries, is recycled informally through backyard recycling. Such backyard recycling techniques include open burning to extract metals, acid leaching for precious metals, unprotected melting of plastics, and direct dumping of hazardous residuals. These practices expose workers to dangerous working conditions that pose great risks to their health and cause serious environmental pollution. Lacking legislation, treatment standards, environmental protection measures, and recycling infrastructure are the main reasons that e-waste is recycled in a crude manner. Let's mention a well-known example. The Agbok Bloshi dump in Accra, Ghana, is one of the 50 biggest dump sites in the world, and perhaps the world's largest e-waste dump. It receives around 192,000 tons of e-waste annually, much of it imported, and pollutes soil, air, and water, and causes serious health problems in the lives of 10,000 informal sector workers gaining their livelihood from sorting and recycling. From the resource perspective, e-waste is a potential urban mine that could provide a great amount of secondary resources for remanufacture, refurbishment, and recycling. For instance, the gold content from e-waste in 2014 is roughly 300 tons. This represents 11% of the global gold production from mines in 2013, which amounted to 2,770 tons. Recovery of such valuable materials requires both high collection rates through formal take-back systems and high recycling efficiency. In order to exploit the opportunities and simultaneously mitigate pollution, good policies are needed. These policies should facilitate the creation of an infrastructure, treatment standards, and should also contribute to create green employment opportunities. In this module, we learned about e-waste. We saw the different types and compositions of this type of waste, as well as the current generated amounts worldwide. On the second half of the module, we covered the 4 existing practices regarding e-waste management. Finally, we mentioned the opportunity that e-waste represents as an urban mine for recovery of secondary resources. For those interested in deepening more on the topic, we strongly recommend the literature shown here, from which many insights were taken for this module.